Hello, and welcome to this edition of EMS Now Up Close. I'm Eric Miskell with EMS Now, and today I get to speak with Oshri Cohen. He's the CEO of Cybord. Oshri, it's good to see you again. It's been about a year since we last spoke.
Thank you, Eric, for hosting me again. It's been some time now.
Yeah. So, I mean, Cybord is in brief, and I'll ask you to cover it. It's kind of an AI-based solution to detect non-conforming electronic components during the product assembly process, right? And it's got I love the history behind the company, and I've seen demonstrations of it. So why don't you give kind of an overview for the audience and maybe people who don't know you of Cybord and the value that you provide to both EMS and OEMs?
Yeah, well, that's a good idea. So I think that what happened during the last year since we last talked was that first our installation base was significantly expanded. So we see much more production lines and much more components, so our coverage first is significantly increases. But I can definitely tell you about some trends that we see in the industry during this period, which I believe would be interesting to our audience. So, first, with the growing traction, we see, unlike last year, we see now more and more EMS guys, and OEM, by the way, but EMS guys open to digest, finally, AI. And, our industry is kind of not running too fast to adopt new technology. We all know this, let's be fair. Yeah. And it needs to be something very significant until it is being adopted. People are super conservative. However, now, during the last year, we definitely can see more and more people interested in the new technology. And people start to realize that if they would like to be able to move forward to the next stage, they must adopt new technology. Well, I mean, the technology today applied in the machines is excellent one, but it's super focused on the process. And material really kept overlooked. And people does not deal with material. Now, if I could show you now the system live, it would be unbelievable how bad the situation of the material coming into the lines. And people now understand this is the situation, so they are more open, definitely more open than what they were in the past. Mm-hmm. I can tell you that we see now we have almost 5 billion components in our database, and by seeing so many components, so first, as I said, our coverage is significantly growing, but more important, the percentage of defects is now really getting sharp. And so we are able to tell you, well, these components are very sensitive, and these are less. I mean, I can show you now a whole series of specific manufacturer, which no matter where in the world, we see those defected, and the others are less. So that's another thing that we can show now. Material condition, if you ask me, material condition is quite concerning. And again, something need to be done probably, and I assume the basic assumption is that the component manufacturer are delivering excellent quality materials. So then you ask yourself, so why is it arriving to the line in this condition? Well, probably it's related to the transportation process and the storage process. Mm-hmm. And people usually buy components ahead of time and keep it in their storage, and not all components reacting the same during the storage period. And if you store your components between 3 months to 6 or a year, or even more than a year, that's a problem. Definitely, we can show you the correlation between the time it was stored and the condition of the component itself.
Yeah. Can I ask a quick question on there? Because that's an excellent point, because I think a lot of people early on for Cybord thought of you as counterfeit part detection, right? But it's more than that. It's also, as you're talking, it's about defects and corrosion issues get detected as well. So it's much more robust than just the counterfeit.
Well, counterfeit is still being covered fantastically by the system. But,
Right.
you know, again, if you narrow the solution only on counterfeit, then, you know, how many people allow themselves to open from unauthorized sources? Well, it happens a lot only when you have a crisis, a worldwide crisis. But today, well, not too much, not too many allow themselves to do this. Therefore, their exposure to counterfeit component is not too big.
Yeah.
But definitely the quality. And by the way, the next topic is the traceability, which is the next challenge I would say I would talk about. These are real issues that we see today.
Mm-hmm.
Let's talk a minute about the traceability. So, you know, initially we thought that it would be very, very useful to allow people to be very accurate with their traceability. And, you know, there is a great equipment and great softwares today deployed within the first tier and second tier manufacturers. So it should be okay. But bottom line, it's still not okay. It's still not good enough. It's still the accuracy level, it's still low. I'm talking here about more than 7.5% of wrong traceability records, all in all. And now imagine yourself, if you're a manufacturer in EMS producing, I don't know, 10 million, 100 million boards a year, well, imagine yourself how much wrong information you move forward, you provide to your end customer, which ends up in huge recalls, and that's a big issue. Now, that's embedded in the process. I mean, it's not that people are not doing good job or the system or the machine are not okay, because there are still people in the process, you know, getting in the incoming inspection, the reels, and they need to scan every field in the reel. That's it. There are people there in the process, or, you know, splicing between two reels in the middle of the night in some shift. Well, I mean, that's the key for these failures.
Yeah.
Now, more important than this, and I think that's the last point in the traceability, is that we see a very interesting trend of EMSs trying to get a solution to enforce real-time enforcement of AVL, the approved vendor list, or trying to get a tool to collect the information of country of origin of all the materials they're assembling. You know, that's something we need to put on the table. This restriction of country of origin need to be managed.
Yeah.
And people find it very hard because they're unable to say exactly what is the percentage of each and every board they build, which is country of origin this or the others, and so on and so forth. And with what we are doing today, since we are based on visual recognition, and since we are being able to operate the pattern recognition by AI and big data, this way we are able to cover 100% of the materials, and anything which is indicated over the component is being covered. And we see this very interesting. By the way, the country of origin is more like the interest of OEMs, and AVL enforcement is more the interest of EMS.
No, that's a good distinction. It really is. And just to be clear, so people understand if they're not familiar with the system, this is, as you indicated, visual inspection, top and bottom, using the installed equipment of the EMS or OEM.
Exactly. We don't ask to add a single piece of hardware that will require anyone to invest additional capex. We are connected through the original equipment machine, whether that's a pick and place machine reporting to our edge computer, or the AOI machines reporting to the edge computer, and we get the information from there, doing all the magic in our edge compute, and then getting back to the line with all the results.
Yeah. And that does not slow down the line either.
Definitely. It's a, you know, I'm coming from this industry, so I'm very much aware of how sensitive it means to put line, reduce the capacity of a line. Therefore, definitely nothing happened to the line, no impact to the takt time. The main reason is because we are acting as a system somewhere in the background, definitely not dealing with the line or changing the cycle time.
Okay, great. Listen, I wanted to, and part of the intent here today is to do an introduction to the new service that you have, RTI, Real-Time Interceptor. And to key that up, we're going to show just a brief video. I'm going to share my screen real quick. We'll run this. It's just about a 1.5-minute video, and then I'll allow you to speak to it. And
Awesome.
for the benefit, I'll let everybody know if this doesn't work, it's because I messed up, not Oshri. So, but I think you can see this, and let me just hit play.
Material issues are the leading cause of electronic malfunctions, leading to expensive rework and recalls. What if you could drop the faulty component early enough in production to avoid scrap? Now you can with Cybord RTI. Cybord RTI can identify, intercept, and eliminate faulty and suspected components before they are assembled on the board. This is how it's done. Integrated into the standard assembly process, Cybord RTI inspects the bottom images of all components in real time, processing them on Cybord Edge computing before analyzing them to identify faults. It then instructs the pick-and-place station to dump any defective component, allowing only good components to be assembled on the PCB, all within milliseconds. Designed for electronics manufacturing services, Cybord RTI ensures that no defective component is ever assembled on your boards. By eliminating rework and scrap while providing crucial insights and monitoring of your component suppliers, Cybord RTI guarantees your compliance with IPC standards. Cybord, the preferred choice of leading electronic manufacturers.
This is exciting. Tell us about this and what brought this about.
Yeah, well, real-time interceptor is it's a product which actually involved due to customer requirements. Well, while we were working with customers, many of the customers came in and said, "Hey, you know what? You're doing a great job, but if it takes you even 10 seconds, then it means that the failed components is already there on the board." Well, that's the case today. And what we're doing today, we are reporting back to the MES system so the board can be diverted aside. And so it won't proceed to the next station, to the next production station. However, some industries, like for example, the automotive, say, well, you know what, if we put a bad component off the board, since we're not allowed to rework the board, it means that we need to scrap it anyway. So, okay, we agree, you could help us with, not keep investing on this board moving forward. But anyway, the hardware, the board, all the components placed already, we need to throw it away. That's a waste. That's a scrap cost, which we don't want to carry. And then they said, listen, once you guys are ready with the real-time interception capability, let us know, because that's going to be the game changer in this industry. And I think it came from there, from this need. And so we had, the main challenge for us was to react super fast. Well, I mean, in few milliseconds, while the nozzle, the nozzle is taking the component. Now there is an image being taken. The time it takes between the images being taken and until the component is being placed can be few milliseconds. Now we need to complete our analysis within this period of millisecond and get back to the machine this time, not to the MES, directly to the machine, and say to the machine, that's a good one or that's a bad one. If it's a bad one, then you should dump it. Do not install it. If it's a good one, proceed as planned. That's the case, and that's the concept of the system. And this is exactly what we did. So the challenge was to run our algorithms fast enough and make sure that the communication with the machine would be fast enough to enable this magic to happen. Yeah. And this is where we are today.
Yeah, and how difficult was that to program into the actual pick and place equipment?
Well, so what happened today is that the pick and place providing our edge computer, of course, by the way, for people who think about it and ask, well, can they do this fast enough over the cloud? The answer is no. We cannot do this fast enough over the cloud. This is the reason we moved to edge compute. So today we have an edge computer on every site. It's just a single computer on every site. You don't need every line or every machine to carry this computer. And this computer actually get all the information from the machine. The analysis is being done, and then we just get back to the machine using a standard protocol that we can communicate with the machine, and the machine understand what they need to do. Of course, we had to get the cooperation from the machine manufacturers. So we will be first with Fuji and then SMTA, and maybe the others will come next. Yeah. But again, we had to make the interface between us and the machine.
Okay, very good. And now I notice at the end of that, it says for electronic manufacturing service providers, who is the solution? I know there's EMS does a lot of manufacturing, but is it just EMS? It is also OEMs. Who's it appropriate?
Well, everyone who produces boards should use and should adopt RTI. Now, usually it would be EMS, but still there are some OEMs producing their own, materials, their own products. In such case, both will be relevant for this. You, as a board manufacturer, whatever entity you are, you would like to make sure that you have kind of an insurance policy, someone or some system holding your back and keeping your back to make sure that you are not inserting and installing any bad or suspected component into your product.
Okay. And just to be clear, you had said before, so this is not yet real-time available. It's called real-time Interceptor, but the RTI itself is being rolled out. It is not currently available. Speak to that and what the time frame is.
Yeah, the time frame. So we expect to see the system fully functional. We assume over Fuji machines is going to happen before the end of this year, and SMPT are going to support this early next year.
Okay, excellent. And then any other pick and place ones that you would
moving forward, we are working now.
When they're moving. That's excellent. Listen, I think it's an exciting and kind of almost a no-brainer, right? Why put it on if you can just spit it out, and that functionality's in the equipment already. So why not leverage it? That's fantastic. Listen, for people who are interested in learning more about Cybord, how should they go about doing that? I know you have some trade shows that you attend, but just speak to that if people want to learn more and reach out.
Right. So we're going to be in SMTA next week in Guadalajara, Mexico. And so you can come and speak with us. We will be in Fuji booth, presenting in Fuji booth. And then in Electronica in November in the big exhibition in Munich. So, of course, we can have some meetings with some people who want to meet us. And, of course, we have our website and LinkedIn and X and whatever platform. We are available in all platforms. And we'll be happy to connect and perform, a demo and then a POC and whatever it takes to, convince a customer. That's a no-brainer, like you just said.
Yeah, no, it really is. I won't be in Mexico, but I'll definitely be at Electronica, so I'll make sure to meet with you there and encourage other people to do the same. So, Oshri, thank you for doing this. Thanks for sharing this. I think it's an exciting evolution within the industry, and look forward to hearing more about it in the future.
Thank you, Eric. Appreciate your time.
You take care.